for the reasons of kind of like demonstration, this is actually a lot of code for what's going on in here. A lot of this stuff can actually be reduced down with some native calls inside GLS. Okay, so the first thing is, let's take care of the stuff that's native. Okay, so you actually don't have to do the Pythagorean theorem. You don't have to do the formula yourself. We can replace all of this, square root, screen space x, screen space x, screen space y, with a function call. And that call is length. So length does the exact same thing as what we just saw there. All we have to do is pass it the vec2, which is the screen space. And it is smart enough to pull out those x and y components and do that calculation. So this is a lot easier to read, right, and see. So that's exactly the same. And then the other thing too is here, this if distance is less than 0.5, circle threshold, blah, 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 blah. We can get rid of all of that too. And we have something called, there's a function called step. And step will go ahead and take that value of distance and then the value that you want to use for your threshold. So I could say 0.5 distance. This is nice. I don't have to replace it 2 different places. I don't have this like complicated kind of conditional. Now one thing is this conditional is a little nice because I'm doing assignment to point 2. This is just going to return a value of, basically 0 or 1. But I can take all of this stuff. I can say just circle threshold is equal to, and I'll just get rid of all of that. I'll just say step. And then I'll put the 0.5 value in, 0.5, and I'll put in distance. And let's go ahead and save and reload. And actually this is giving me the inverse of what I want. It's giving me 0 here and 1. So of course, if I want to have the opposite of this, I can say 1.0 minus. And there we go, that gives me that. So step is actually giving me 0 inside of the 0.5 step and 1 outside of the 0.5 step. So it's an inverse threshold here. We need to invert it there. Okay, so right away that cleans up our code. It's a lot easier to read. There's a lot less kind of writing. And then the last thing is there's a native variable in ISF for this because you refer to this, you do this so often, this normalizing of the fragment coordinates that they went ahead and made a variable for this ISF no, frag norm frag coords, frag norm coords, either frag norm coords or norm frag coordinates. Frag norm chord, and there we go. That good, good that worked. Okay, so I'm glad I brought that up because if you go on interactiveshaderformat.com and there's right here, if you say learn more about ISF or you want to check out the spec, open link in new tab. Actually, everything the good dudes at Vidvox have actually written all these variables down. So I didn't memorize these ISF created variables. I had to look them up for these uniforms, and that's where I was able to find out about ISF frag norm coordinates. So you want to read through this documentation. Great, and it's actually not too bad. There's some stuff in here that we're going to cover in our training series. Okay, so yeah, ooh, all right, we made a circle, hooray. The next thing I'd like to do is actually be able to like control the size of the circle dynamically inside VDMX. We're starting to get at something that's like actually maybe a useful generator, like something that can just make a circle, put it on screen where we want it, and scale it up and down. So for that, I'm going to need to create some user data, basically some data that is going to be kind of like the bridge between this ISF and VDMX. There's some other things too, obviously, that I'm probably going to want to do, besides just having this be a value of 1 all the time. I'm probably going to want to pass in a color so that I can, set a fill for the shape, for the circle. Then, yeah, what else is on our list? Let's make some rectangles besides some circles. Let's make more than one shape. And then you'll notice I replicate the shapes quite a lot too. And so for my ShapeMaker ISF script, I used something like a for loop, like a loop that would create these things over and over again. And if you want to create a bunch of circles over and over again, it makes a lot of sense to create something more like a function. Like maybe we can make a new function, which I think probably would be a good idea to make a function that's called circle. And then whenever we call circle, it'll just generate circles. So we can like take all this, pack it all up and put it inside a function called circle, and then just like call that circle function. So we have a lot to do. We have all of that to do coming up soon. Let's go ahead and take a look at first. I want to start making this thing really useful in VDMX by adjusting what's up here inside the JSON. All right, so the next thing we need to do is take a look at this upper area of our script right up here. And this is kind of lovingly referred to as the JSON dictionary, or the JSON dict. It is also sometimes referred to in the documentation as the JSON blob. And this is basically the area that's kind of the interface between your host application, which in this case is VDMX is our host. It's hosting the ISF file, and this code that you've got down here, your GLSL or shader code. And so this area in here, this is where we can write some stuff that will have these two things talk to each other, basically. And so what is this up here? This is actually right up in here. This is actually a slightly different format than this code here. I wouldn't go as far as to say that it's a different programming language, but the way in which you hold data in here is in a format called JSON. And JSON stands for JavaScript Object Notation. And basically, you just need to know two things about JSON. You need to know the two data structures of JSON. The first is an array, and an array in JSON looks like this. It's two square brackets, and inside that array is a list of stuff. So let's just add some stuff inside our list. We could say like 3, 5. If we have some integers in here, you could put in strings in here, like, red, green, and blue. You could put in floats in here. This is just a list, and we're going to use the array quite a bit. To get stuff into and out of the array, you use the array's indexical addressing, which is a really fancy way of saying which part of the list it is. So as an example, if I had an array which had in, let's say I'm getting out red, green, and blue. Let's say we got red, and we got green, and we got blue. Then the first place in the list, it's the first index of the list is 0, index 0. So this would actually return red if the name of this array was array. So let's say we had a new array and we're referring to this array up here. We would use the name of the array and then the square bracket syntax to pull that value out. And then if we wanted green, of course, we'd say 1, blue, 2, etc. Okay, great. So that's an important thing to know about. And then the other way in which JSON holds information is another list, and this one's called an object. Again, we use these curly brackets here, and we use them for code blocks down here, so they're actually kind of different. This is basically the same thing as an array, only instead of having a numbered list, like the index of 0, 1, 2, 3, 4, etc., it's got names for the places of the list. So, like for example, these are called the key and the value pairs. So key value pairs, right? So, and then when we want to pull something out of the list, we do it with what's called its key. And then we have the same thing here. It's separated by commas, just the same as the array. And as you can see, it looks really similar to the array, right? It's just kind of a list of stuff. And so, like as an example, let's say we had a key called pizza, and the pizza has a value called cheese. Then let's say the name of our object was lunch. You guys can tell I'm hungry. And I could say lunch.pizza. If I go up to there and I say, give me the lunch.pizza, that's going to return cheese. It's going to return the value when I query the key. Great. Okay, so there we go. You know everything you need to know about JSON as far as ISF is concerned. There's a bunch of preset key and value pairs that they've programmed into ISF that your host application may or may not understand. As you can see, all you need to do is actually create a JSON blob, just an object, and then it will render here in VDMX. But there's a few things that VDMX is probably going to expect. And the first thing is a version number. It's really nice to know which version of ISF you're using. And if you don't put this in, it's going to assume ISF version 1. And so they've changed some stuff between ISF version 1 and version 2. And so you want to make sure that you let the host application know which version of ISF you're using. And there's some features to ISF version 2 that we won't go into right now that are a little bit different, kind of a little nicer. They're cleaning up kind of the syntax, that sort of thing. Another thing that's nice to put in here is like a credit. So I'm going to add a credit to the list, and the credit is going to be the person who is creating the script, which is going to be me in this case. And you can put links to your address or whatever, if there's other accreditation. Or what's also really common here is to port a GLSL around the community. Lots of people like kind of port functions or port code around, and it's really good to attribute where you got that stuff because a lot of times people just kind of borrow code. This lets you say like, hey, this came from here, that function came from there. You can give accreditation to the people who wrote all that cool code that you might use. You can also put in like a description here of what this ISF file is and what it does. This is the ShapeMaker. Will be eventually. You can put in a version number actually of your script, and this is going to be version 0.01, and we'll rename this from test to ShapeMaker.fs. And then if your host application supports categories, you can put those in as well. So like, for example, maybe your host application supports a category is called generators, and it will look for that category here, and this has to do with like these assets right in here. So this is going to be if I have a generators category or a geometry category, it'll add it automatically. That's not the case here, and it doesn't really. This is all optional stuff, but it's good to know about. Okay, so we're through some of that stuff, that boilerplate. By the way, you don't have to write this every single time. I'm going to show you guys. Oh, forgot a comma. I'm going to show you guys how the ISF editor, when we get there, will actually create some new. It'll basically spit out all this for us. It'll spit out all this JSON, and then you can just change the values rather than have to hand code all this stuff. Okay, very good. So the one that we're going to be most interested actually is a key called inputs. And inside inputs is where we can actually put in some variables. And then we can drive the code down here with the variables. So this lets us create like an interface. So first with inputs, it's all held inside a big array, which you can see what I did just right there. I instantiated a new array. And then inside that array are going to be a list of objects. And yes, objects can be packed inside arrays. Arrays can be packed inside objects. They're just lists. So this first one, let's go ahead and let's call it, let's give it a name. And the name is going to be, let's use something like circle size maybe, because we're going to go ahead and replace this value right here with a variable. So name circle size, and it is a float, and we can use all the same data, basically the same data types that we're using down here. We can duplicate up here. We just have to be clear about what they are. And then I'm going to give it its value, which is called the default value. And the default value is going to be 0.5. Notice this is not in quotes. So these are called strings. These strings are parsed by your host application, and then something useful happens. But these are actually in just kind of like hard data, and that's because JSON supports the same type of data as GLSL. So you could try and keep it as the same data if they can. So the default, and then let's make a min value. We're making the bottom and top of a slider now. So I'm going to give a minimum value of 0.0 and a maximum value of 1.0, which is also pretty common, right? Okay, so let's save this and let's execute it here inside VDMX. I've just refreshed, and cool, look at that. Inside of VDMX, inside layer 1 source, there's a slider. If you come inside the source and come into this thing that says ISF interface, that's what we just built. We just built an ISF interface. Cool. So we've built our own slider. Hooray. It's not hooked up to anything, so that's definitely what we got to do next. I'm going to come down here to my code. And actually, when I declared the name up here inside JSON, that's what my variable name is going to be down here. So I'm just going to replace this hard number with circle size. And this, my friends, this is going to be your new thing you are going to do all of the time. You're going to find hard numbers down here, and you're just going to replace them with sliders. You're going to launch that into VDMX, and then you're going to take this and you're going to, assign this to the beat. Basically, this is every time you see a hard number down here, and you're not quite sure if the hard number should be smaller or bigger, make it a slider, and then that way you can interactively adjust the value. Cool. Okay, so the next input I want is going to be let's do a color. So I'm going to give this a name of, what do you guys want to call this? It's called fill color. And let's give it a type. Now the type here is going to be a different type. It's technically a vec4, but they have kind of made this a little bit more human legible as color, a color type. And let's give it a default value of this. Now all this is held inside an array, and the default is going to be, let's make it red, and 0 in the green, 0 in the blue, and 1.0 in the alpha. Great. Okay. So this is now, if you're handwriting this stuff, look at this big pile of thing that you can mess up right here. Right. This is an array. Got to make sure this is closing. That closes that object. That closes the array of inputs, and this closes the JSON object. So all you have to do to mess this up is to like delete that, and nothing. It will not compile, and everything will break. So you do have to be really careful with these to make sure every time you open something, you close it. And actually, once again, once we get to the ISF editor, which we're about to do here, it'll throw a little bit of a useful error here that gives you a hint of that. So let's just go ahead and save this, and let's come back over here to VDMX, and sure enough, look at that. Now we've got a fill color interface. So that's really cool. We have this cool interface here inside of VDMX. It's the color. This takes this out and parses it out, and we have all the cool modes that we can do with VDMX, like go to hue, saturation, and value instead of RGB. We can sample a color if we want. That's very cool. Okay, so we need to replace this fill color down in here. But actually, so I notice here that it's not as obvious where we should put this, right? Like I didn't actually ever assign a color value anywhere. All I assigned actually is white. Like I have a float value that's returning like a 1 to 0 based on the pixel that it's in. So how can I make this kind of square with this? Well, what I need to do is I need to determine that particular pixel, whether it's 0 or 1. And then what I'm going to do is I'm going to multiply that pixel by this value. And if that pixel is inside of the circle, that means they're all going to be 1s. And let's change this from 1 to, let's say this is like 0.5. So if this would be, let's say our pixel value here is 1. That multiplied by 0.5 is going to keep the value the same. If the pixel value is 0, which means it's outside of the circle and it multiplies, then it's going to turn this number to 0, because 0 multiplied by any number is 0. And any number multiplied by 1, of course, equals itself the same. So what we need to do is we need to take these values, wherever this is, becomes a vec3, which seems to be right here. Notice like right here it says vec3 circle threshold. And we need to multiply that by our fill color. And we don't want to multiply by just the fill color, because remember this actually is 4 values. This is going to throw an error because this is a vec3. And I'm multiplying it by a vec4. So what I need to do is I'm going to pull out just the RGB, and I'm going to multiply it against the RGB that I'm generating right here. And let's go ahead and let's execute that. And okay, this is it's close. It's not quite what I want. I wanted to have this color be inside of there, and I think that's because this is where I've chosen to inverse right here. I'm inversing down here, so I need to inverse this basically earlier, right? So I could do 1.0 minus here. Oops. There we go. So this solves the problem, because I was doing this multiplication before I was inverting the color, so I need to invert the color just earlier. And I think probably it makes more sense to do it here anyway. Well, no, this is kind of the threshold. I think what actually makes the most sense is to do it here, because that's the color that I want to return. Like this is the threshold calculation. That's the color that I want to return based on that circle threshold calculation. And because I'm compiling the color here, it makes most sense to also consider the color there. There, I think my code almost makes sense now. There we go. Cool. So yeah, like right away, this is actually something that's kind of useful. Like I can just quickly create an audio
analysis here, and let's just use that as my data source. Hello, and immediately I'm making something useful in VDMX. So the next the next stop here is we're going to actually leave VDMX and we're going to leave Sublime Text, and we are going to jump into the ISF editor. The ISF editor is going to, you notice already, right? We're kind of running out of room here inside Sublime Text. This is going to be of limited usefulness to us to just be building our ISF files in a text document. You certainly can do it. There's nothing wrong with just using a text editor to author these things. But the ISF editor has a ton of really awesome features that VidVox has built in, so I'm excited to share those with you.